Okay. But can you hear me? Let me just check real quick what's going on here. I'm not sure if I'm audible there. Chavi beta, if you can hear me, you just might want to unmute yourself.
Hello, sir.
Yes, beta.
Yeah.
Okay, beta, let's get started. The other students will not be joining us today. There is something going on in parallel, but they have done this part. So I'm just going to be focusing. So you and I will just focus on where we left last time, and then carry on from there, beta. So we'll start with the relative velocity, question type number 10. Question type number 10. So basics of relative velocity, we have already spoken about the relative velocity and what it means. So when we say relative velocity, we are referring to velocity of one particle with respect to another moving particle, right? So if you have two particles A and B, if you have two particles A and B moving with velocities VA and VB, then the relative velocity of, let's say, A with respect to B will be vector VA minus vector VB. At the moment, we are talking about one-dimensional motion. So in one-dimensional motion, we don't need to worry about the vector algebra, but we do need to worry about the signs. So if you have particle, let's say A and B, both moving along the same straight line. Let's say this is A, this is B, A is moving in this direction, let's call it VA, and this is moving in this direction, VB. Then the relative velocity of A with respect to B will be VA minus VB. Now, because VB is towards the left, so if you assume that the positive x direction is towards the right, then assuming that VB is just the magnitude of the velocity, V and VB, then we'll write it as VA minus of minus VB, because VB is towards the minus x direction. So that will be our relative velocity. In other words, it will be VA plus VB. If both were moving in the same direction, so let's say A is moving in this direction and B is also moving in this direction, then the relative velocity of A with respect to B will be VA minus VB. Now, depending on the relative magnitudes, if VB is smaller than VA, then as seen by this particle B, particle A is approaching it. But if VB is greater than VA, then B will think that A is actually moving to the other direction. Does that make sense, beta?
Yes, sir.
Okay, so let's go ahead and solve a few questions. We'll try and solve a few questions, maybe. Okay, there are only 3 questions, so let's pick with this one. JEE Mains 2020. I think we have done this one. I think we did this one in the previous session, or maybe in the session before that. Let me know if you want to redo it, beta.
Yes, sir. We've done this.
Yeah. So इसमें क्या? So what's going on here? So you have two trains moving in the opposite directions. Now the speed of both the trains is given. Then it is given that there is a person walking on the train A in the direction opposite to its motion. So you can assume, let's say, that A is moving towards the right, which is the positive x direction, B is moving towards the left, and then the person is moving towards the left with respect to A. So first find out the velocity of the person with respect to the ground, and we already know the velocity of the train B with respect to ground. Then to find their relative velocity, we will do V person with respect to ground minus VB with respect to ground. In other words, if there are more than two particles, first get their velocities with respect to the ground, and then you can quickly or easily figure out the relative velocity with respect to each other. Let's look at the NTA Abhyas question, beta. There's something funny about this question. Let me just quickly double check whether this question statement is right or not. Now, why don't you go ahead and attempt the JEE Advanced one while I look at this one, okay?
So this would be B, right?
Statement 1 is true, statement 2 is true, statement 2 is not a correct explanation for statement 1. So let me quickly just give me a quick second. I'm trying to figure out the previous one. Where is it? No, it does claim that this is right. The 6 kilometers upstream in 6.5 hours. I see. Okay. Okay. So we'll go back to that question. I think that's a fairly good question. Let's look at this one. For an observer looking out through the window of a fast moving train, the nearby objects appear to move in the opposite direction to the train, while the distant objects appear to be stationary. Okay, statement 2 says if the observer and the object are moving at relative velocities v1 and v2 respectively with respect to the or with reference to a laboratory frame, the velocity of the object with respect to the observer is v2 minus v1. Okay, that is correct, and even statement 1 is correct. But can you explain why or how would you explain statement 1? It's very clear that statement 2 will not explain statement 1, but can you explain the reason why statement 1 is true?
So honestly, I thought of it because like this is what I have noticed.
Yeah.
Uh, but so I think it, I'm not sure, but from what I notice, I think it has something to do with like maybe the angle, because like when it is really far away, the even though you're moving a huge distance, the angular like the angle that changes is like not a lot, right? But close by the I don't know, is that making sense?
Yes, Peter, you are making sense. Yes.
And then like when it's close by, even though you're moving a small distance, the object moves like with a bigger angle, so it looks like it's moving a lot faster because it has a bigger like displacement.
It's actually very easy to replicate. So if you take your, let's say your index finger and move it in front of your eye, very close to your eye, right? This is a small distance at that speed, right? So what will the eye see? I will see something that has passed by very quickly, correct? No? And but if you keep the finger away, it doesn't feel like it is moving that quick, right? Because what eye sees is when you are sitting in the train, right? So let's say this is the train, everything is the train. So when you're sitting in the train, then for a far away object, let's say at t equals to 0, you are here, then your train moves, then you actually come here. So your angle has changed by this much, right? So your eye registers a change of this angle theta. Yes?
Yes, sir.
Because we are reading that angle beta, how quickly that angle is changing. Yes. And but when somebody is very or something is very close by, so let's say the object was here, then look at this angle. The angle is much bigger, no? When something is close. So from the perspective of our brain, the eye has seen that something is actually gone from kind of at a very sharp angle very quickly. So the eye perceives that something has moved very quickly in front of it, right? So brain thinks that it's actually moving very fast. So how do we judge that something is moving fast, right? So we see how quickly it moves in front of our eyes. Yes, how quickly it goes from, let's say, the right to the left or left to the right. That's how we see this. That's how we judge the speed, na beta?
Yes, sir.
Yeah, that's the simple way our eyes and our brains work. As simple as that. We are actually looking at the change in the angle to perceive the speed. Yes, Peter?
Yes, sir.
Yeah. Okay, so let's move on to the next one. By the way, this was the lateral movement. Have you ever noticed that if something is running right at us, right at us, it's not that easy to judge the speed
Yeah.
than the lateral motion. It's very easy when something is moving laterally. Okay. Let's go back to this question. Let's give it an attempt. So upstream is in the opposite direction to the travel of the water, right? If the water is flowing in this direction, then this is upstream.
So I think I got the equations. I just have to solve it.
Okay. just to make sure that there is, because the statement is not very clear, right? So just to clarify, the board is covering the 24 kilometers plus 36 kilometers in 6 hours. So it's covering the 60 kilometers in 6 hours. While it covers 36, again 60 kilometers in 6.5 hours. But now it's switched, how much upstream, how much downstream. So, Beta, how will you do it? How will the boat do it? So it will travel perhaps, let's say 12 kilometer downstream, or say 18 kilometers downstream, comes back, or not even, let's not even think that way. Let's say it goes 24 kilometers upstream and then it travels 36 kilometers downstream. In 6 hours.
So it's becoming lengthy.
What is it, Bidhan?
Wait, oh wait, no, everything got cut. Hold on. So is the answer 2?
Sorry, let me just quickly draw it. The answer is 2, yes. Okay. ठीक है बेटा. So is this how you did it as well? Or did you just simply take velocity with downstream as one value, one variable, upstream as another variable, and then kind of later on subtracted the two to get the relative, or to get the V river?
So I took, yeah, so that's what I did. I took like the velocity of the river as x and velocity of the current as y.
Okay.
And then I did like distance by velocity's time, right? So I did 24 by x minus y plus 26 by x plus y is equal to 6. And the similar way I did for the other situation, and I treated it like a pair of equations.
Excellent, excellent. That's it. Okay, let's move on, beta. Let's go to the next type of question. Today, our target is to reach till the question type 14. So we want to finish till 14. So in this one, we're talking about the relative position of two particles moving at the same acceleration. And again, the motion is in the one direction. So one example, one such scenario would be if we throw a particle, or if we throw two particles from say a certain height, one you throw upwards, another you throw downwards, or you can throw both of them upwards at different speeds, and then you might be asked to determine the position of one with respect to the other. How will you do that? We spoke about it the other day, but essentially if you have let's say this is particle A, this is particle B, and we are trying to find out the position of A with respect to B. So it's very simple, just like what we have for the relative velocity. So figure out the position with respect to coordinate system attached to the ground. Then find out the position of B with respect to the same coordinate system and the same origin. Then relative position of A with respect to B will be YA minus YB. So this is the relative position of A with respect to B. It's that simple. I think we have done one of the questions, but let's go ahead and
So I did not understand this completely, especially like if you take a scenario where like something is being thrown up, and then like two things have been thrown up at different times.
Right?
Like obviously the acceleration on them is minus g, but I did not understand how would you calculate the relative position.
Aha. Um, so there can be a couple of scenarios, or there can be, yeah, there can be four or many scenarios. Let's talk about one of them. So let's say particle A is thrown upwards at t equals to 0 with some speed VA. Okay. Then let's say you are given that the particle B is thrown um, upwards or downwards after a certain time delta t. Okay. So, and let's say you are asked to determine the expression for the relative position. So for the first delta t seconds, B is stationary, then relative position of A with respect to B is YA minus YB. If you, let's say your origin is attached to the point from where the two particles are launched, then YB is 0. So it will simply be YA. So you will simply be tracing YA. How will the YA change? Well, S is equals to UT plus half A T square. So this will be a quadratic equation, right? So it is going to go up and then come back down. So will it be like this, Peter? Would you agree?
So this is a position time graph.
But Chavi, आपकी आवाज, your voice has gone out.
Sir?
Yes, Peter.
So the graph is the position time graph.
Position, relative position, time graph. Relative position and time graph.
Yes, sir.
Okay. Can you see that this is a parabolic equation, beta? This is a parabola, equation of a parabola.
So
Write this as YA plus minus some constant is equals to some constant times minus of some constant times t minus b square.
So I'm not sure I know what a parabola's equation is.
Okay. So let's talk about a couple of different equations. So y is equals to 4a x square. Y is equals to 4a x square. So for such a scenario, how will this look like? This will look like this. So for plus x, let's say this is x, this is y. So for plus x and minus x, the values will be the same. At 0, it's 0, right? So this is how it looks like.
Yes, sir.
Okay. How will y is equals to minus 4ax square look like? Just invert it. So this will be y is equals to minus 4ax square. ठीक है बेटा?
Yes, sir.
Okay. Now the other scenarios are, let's say y square is equals to, in fact I should have written x square equals to 4ay, but that's okay. Let me change it right now. So this will be the standard. So 4ay is equals to x square, and here I should write minus 4ay is equals to x square. If I were to write y square is equals to 4ax, how will this look like? This is x, this is y, then this will look like this. right?
Yes, sir.
Okay. Now, if you were to write y square is equals to minus 4ax, it'll just be the inverted parabola. That's also clear. So this is y square is equals to minus 4ax. This is y square is equals to 4ax. Now let's do one more thing. Let's write, for example, in this scenario, because this is what we are trying to plot. Let's say we write 4a y minus y0 is equals to x squared. Okay? Yes, Peter? Y, 4a into y minus y0 is equals to x squared. So how will this plot look like? Any guesses?
So I think the normal the y is equal to ax square graph that we made, would it just start from like higher?
Just like this, what I've drawn here.
Yes, sir.
Okay. If we were to write this as 4a y minus y0 is equals to x minus x0 square, how will this look like?
So it will shift on the x-axis.
So at x equals to x0, y is equals to y0, correct?
Yeah.
Yes, Peter?
Yeah.
Now if I were to write 4a minus y minus y0 is equals to x minus x0 square. So can I make this plot like this then?
Yes, sir.
Okay, excellent. Excellent. So this is the graph we are getting there. That's the graph I was trying to draw. But this is the equation. So you're going to study parabola, hyperbola, ellipse sometime towards the, well, it depends when you guys are going to cover it, but you should be starting on it in 11th. Okay, so let's move on to what happens when B starts to move, right? So we've already plotted for the first delta t seconds. Now, after delta t seconds, B has also started to move, correct? Right, Beta?
Yes, sir.
So at that point, so your equation for YA would be, let's say YA is VA t minus half GT square. For YB, after time t is greater than delta t, YB can be written as VB. Now to time duration would be t minus delta t minus half g t minus delta t square. This is one of the ways of writing the equation. It all depends on how you define your t. When do you say the clock starts at t equals to 0? But in any case, this is how the equation would look like. The two equations will look like. Now if you subtract the two, you will get the expression for relative position of A with respect to B. Yes, Peter? If you are okay, let's practice this art, let's practice this concept with a few sample questions here.
So in after delta t, why is the equation for ya still having t square? Like why not t minus delta t?
Oh, for A.
Yes, sir.
Aha, okay. So for A, let me write it back again. So I said for YA, this is, look at the initial velocity that I'm choosing. This is when A was launched, right? So from there, I'm measuring my time duration from that instant when A has been thrown upwards, when it has been launched upwards in air, minus half gt square. So time duration is constantly being measured from that point, from the launch point. If you want to change that, and if you want to make it the same as the time duration for B, then what you have to do is you will have to figure out what is YA at t is equals to delta t, right? What will that be? That will be YA is equals to VA delta t minus half g delta t square. Yes, Peter?
Yes, sir.
Okay. Now, when you write the equation for, let's say, the y for the position A, let me just call it y dash A, now measuring it from that point. So now we're assuming that actually you've defined your new t equals to 0 when A is, let's say, somewhere over here and B has just been launched. Correct?
Yeah.
Expression for that would be y dash A, because there's a displacement is equals to initial velocity into t, right? So y dash A minus ya is equals to initial speed. What is initial speed now at this point? VA dash. What will be VA dash? VA dash will be VA minus G delta T. That will become the new initial velocity at that time. Once again, we have reset our clock to start measuring from this point into, now you can write it as T minus half G T square. So now if you were to substitute, you will get YA dash is equals to YA, which is VA delta T minus half G delta T square plus VAT minus GT delta T minus half GT square. So if you assemble this thing, your equation will become, this will become an interesting equation. Okay, so we are saying T, so we should say T minus delta T, but that will not be right. But anyway, so that's how you will write it if you measure time from this point, beta. If you say this is my T equals to 0. Okay, so the equation gets slightly more complicated. But if I keep my clock, measured from this point, the initial point of launch, then my time duration for A is always measured from the point of launch. So this remains my initial velocity. So I can straight away write my expression like this. Now when it comes to B, when I'm writing it for B, so B will be initial velocity, which is VB, into time duration. If let's say, let's take some numbers. Let's say delta T is 5 seconds. And we are writing it for T equals to 10 seconds. So when trying to find the displacement for A, you will put T is equals to 10 seconds. Yes? But
So it's the 10 seconds is again the time it takes to, or is it total time, and delta T time after which the second
T
ball
10
is.
seconds is just any random time. So let's say you are trying to find the displacement of A at some time T equals 10 seconds. Then what equation would you use? You will write Y at that time, YA is equals to initial launch velocity into 10 seconds minus half G into 10 square. Yes?
Yeah.
For YB, what will you write? Whatever the initial velocity VB into time duration. Now it's only been 5 seconds since the launch. Yes? So you'll write like this, minus half G time duration squared. That's how you'll write it, Nabita?
Yes, sir. Yeah, I got it now.
Got it now?
Yes, sir.
let's solve a few questions. So we'll do one from JEE Mains. Let me just see if you have any questions from 2020 and 2019. They are relatively more exciting. Well, they are not. Okay. So let's go ahead and solve this one. But while you are working through it, I'm just going to start scribbling, so you don't need to look at my screen. Um,
So I think I've solved this question before.
you solved this question before?
Yeah, I don't remember the answer, but I think I've solved this before.
Okay. In that case, let's go ahead and do the next one. Let's do NTA Abhyas questions.
So 25 meters?
25 minutes. Okay. Yeah, nearly 25 meters, right? So I'm assuming you have taken 10.
10, yeah.
Well, actually, it should be in the two-dimensional motion, but since it has been it has showed up here, let's go ahead and solve this one. Or let's do this, Chavi. We'll not solve this one. Let's go ahead and attempt the next one. And I would say we have solved this one. Right, Beta, we have solved this one, no?
So answer would be B?
Answer would be B. Okay.
Yes, sir.
Let's go ahead to the next question type. So So once again, we talk about motion along the one dimension, and we are talking about two particles, their relative position with particles moving at different acceleration, but the accelerations are constant acceleration. So we can still use the v is equals to u plus at and s is equals to ut plus half at square. And once again, the relative position is of a with respect to b would be relative position of a with respect to some origin on the ground minus relative position of b with respect to the same origin on the attached to the ground. Let's look at the NTA Abhyas or maybe JEE Advanced Question. See what do we have here. Okay, so there was a 2014 question. Interesting question. Let's give it a try. Let's give it a try. Yes.
So I don't think I got this question.
That's fine, brother. Let's quickly go through it. So there can possibly be two things that might be happening. And the reason the answers are given like this, and I need to check if this is how JEE Advanced paper laid out the answers. Um, we need to check. But there are two possible scenarios. What are those two scenarios, right? So scenario number one, um, so A is launched and B is launched, right? So A is launched towards right, B is launched towards left. Now, once they leave the rocket walls, they are traveling at constant speeds. They are not accelerating anymore with the rocket. Yes?
Yes, sir.
Then scenario number one is that um, they hit each other without rocket interfering anywhere, right? So if you do that, then you will write the equation as for B. For B, assuming that it is traveling to the left, you wrote this as 0.2 minus UR. Right, beta? 0.2. What is UR? UR, I've assumed that the speed of the rocket towards the right is UR at the time of launch. Correct?
Yeah, okay.
So the speed or the velocity towards the left is 0.2 minus UR, right? Recall the relative velocity is आपका so what is it? V relative is of the, let's say, what is it, the object? I'm going to call it, let's say it's another ball. Okay, so I'm going to call it VB, VB2, right? So VB2 with respect to the ground minus the V of the rocket. Let's say you're assuming left direction as positive, correct? So you will say the V relative, which is 0.2 towards the left, this is equals to VB2 minus, now the rocket's speed is UR towards right, so in this new coordinate system it will be minus UR. So VB2 0.2 minus UR. Peter, was it slightly tricky to write it?
Sir, I think the mistake that I made was, first of all, I assumed that the balls would have the acceleration of the rocket, which does not make sense now that I think about it.
Yes.
And secondly, sir, when I was taking the relative velocity, like the velocity with respect to space or ground of the balls,
Yes.
in both cases, I added the velocity of the rocket instead of subtracting it in the negative direction.
Okay, okay. So those are two good learning lessons, Peter. Right? Nothing wrong in it. We did that train problem where the train was moving towards the right, the person was moving towards the left. Correct, no, Peter?
Yes, sir.
So at that time we said the relative speed was towards the left. So we said with respect to the ground, it will be the speed of the train minus the speed of the relative speed. We did something like that. But this will need a slight practice. Just think through it. Just think through it. What will happen if the same scenario, train is moving towards left, the person is moving towards the right, what will be the speed with respect to the ground if you are given the relative speed of the person with respect to the train? In any case, so if you do that, beta, then you write SB and SA. If SB plus SA is 4 meters, then they would have met each other, correct? So when you do SB plus SA is equals to 4, then you get your answer as 8 seconds. What is the other scenario? The other scenario is that you threw the first ball towards the right at 0.3, but the rocket catches up because rocket has an acceleration of 2 meters per second square, no? So within a second, its speed is going to increase by 2 meters per second. So sounds like it's going to catch up fairly quick with ball A. So what will happen? So you threw the ball, but then again the rocket came up, it came from behind, and the ball would be then carried away along with the rocket, right? So then you need to work out how long will it take for ball B to hit the left wall of the rocket. Yes, then A is out of the picture now. Now you're trying to figure out how long will it take for the ball B or the second ball to hit the left wall of the rocket. So if you do that, then you write your equations as SR. So let's say the rocket left wall has moved a distance of SR towards right, and the ball B has moved SB distance towards the left. Their sum should be 4. So if you do that, then you will get the answer as close to 2 seconds. Take it up?
Yes, sir.
Okay, good. Let's move on. Now we're going to get into the two-dimensional motion. And before we get into the two-dimensional motion, the projectile motion, let's first talk about the, let's get familiar with some basic things such as the displacement in the two dimensions, or the velocity in the two dimensions. So let's get comfortable with that concept. So in this one, the very first one, what do we have here? So we have a particle that is moving in two dimensions, and let's say it moves from some initial position. So let's say this is your X and this is Y. So it moves from some initial position to some final position. So let's say this is XA, YA, and this is XB, YB. So if somebody were to ask you what is the average velocity if the time it takes to go from A to B is, let's say, delta t, then what will be the average velocity for this scenario? Once again, average velocity is defined as net displacement divided by the time duration. So what is the net displacement? So if the particle goes from here to here, so this is the displacement S. And how do you find this S vector? Remember, displacement is a vector quantity, and so is the average velocity or velocity. So to find this, we recall that this is your position vector RA, and this is your position vector RB. Then the displacement is position vector of the final position minus the position vector of the initial position, RB minus RA. What is the position vector of point B? Well, that is simply XB I cap plus YB J cap. Once again, what do we mean by position vector? The vector that joins, that has the tail at the origin and the head at the given position. So that is your position vector. Similarly, RA is XA I cap plus YA J cap. So what is RB minus RA? That is XB minus XA I cap plus YB minus YA J cap. Are we clear, beta?
Yeah.
So then your average velocity, I'm going to write it like this, will simply be 1 by delta t xb minus xa I cap plus 1 by delta t yb minus ya j cap. Now this is slightly foreign to, or slightly new for the students at this stage to work in two dimensions, to work with vectors, but it is of highest essence that we become comfortable with the vectors. So where does it all come in handy? Um, so it will be definitely of quite a bit of significance in chapters such as, let's see, 12th, definitely, absolutely, from electrostatics to magnetics, even to the induction and well, optics, maybe not that much, but EM waves, yes. In 11th topics, where does it become very important? It is going to become important in rotation for sure. Now, in other places, simple harmonic, not really, waves, not really, properties of matter, not really, except for a few places here and there. The force and motion, in some types of questions, yes, it will become very important. But if you want to have success down the road, it is absolute a must to become very comfortable with vectors in 2 or 3 dimensions. Okay, but are we clear now? How do we find the displacement vector and the average velocity for a 2-dimensional scenario? Clear, Navita?
Yes, sir, for now.
Okay, so let's go ahead and attempt 1 or 2 questions. This is a 1-dimensional scenario, but because we didn't have any specific category for average velocity, it has been put in here. But hopefully the other 2 questions will test us on the 2 dimensions. But if me writing is going to distract you, you let me know, I'll wait.
No, that's okay, sir. So is it 18 meters per second?
Yes, Peter. Let's go to the second question.
So questions like these is just easier to take an example and solve it, right? Like, so you were doing it, I just saw it for a moment, but like you were solving it using an equation. But instead of that, isn't it easier for us to take an example, like a assuming value and solve it?
I'm still trying to understand what you mean. What you
So, like for example, I take the total distance to be something.
Oh, I see. Okay, so you said if I just put in the values right there and then,
Yes, sir.
rather than carried in the expression.
Yes, sir.
Yeah, yeah, Absolutely, you can do that. For JEE Advanced, you typically would want to work with the variables. It is helpful, but again, it's your judgment, Peter. So whatever gets the job done quicker for JEE Mains, that's good. Actually, both are going to be equally effective. Might be a 10 seconds here and there, but that's pretty much it. Yes, Peter?
Yes, sir.
Okay, let's do this one. I just want to get to the next one as well, and then we'll take a break. Let's go ahead and attempt this one. Yes, Peter, are you coming along okay?
So I think it's B.
B, that is correct. Just a quick one. Would you find time to do more of these problems from the website, Peter?
So at home?
Yes.
Yes, so actually I had exams for the last 2 weeks. Today was my last one, so now I have time.
Oh, excellent, Peter. So now we will be running at good pace, right? Because in Centum, where are you right now? You have covered kinematics. You are getting into force portion now.
Yeah, so I think we'll start by Monday.
You'll start by Monday, right? So typically, what happens is we will be maybe a topic behind initially, which is a good thing because it's a kind of a revision, right? So Centum is one chapter ahead, and then we are one chapter behind. But by December, we will catch up, and then by March or April or May, we will be 2 chapters, 3 chapters ahead, right? So for the 12th batch, we are starting with the optics and EM waves in the coming week. So we are hoping to finish everything in mid-September. Okay.
Right, sir.
So that's how we're gonna go. But anyway, let's go ahead and take a quick peek at the NTA Abhyas question. Let's take a look at this one, beta. Let's do this one real quick.
So 8 I cap plus 6 J cap?
Yes, that's it. That's simple and straightforward. Now, we'll talk about the angle between the vectors. We'll pick this question type in the next class as well. But from the vector algebra, are you comfortable with the vector algebra, beta?
So I have done it definitely, but I have actually today even in the exam I struggled a bit with it.
Okay, so we'll do as many questions as needed. This one and the next question type in the next class, tomorrow's class, right? So
Yes, sir.
basically, understand one of the very important and helpful vector algebra equation. What is that? The magnitude of any vector, let's say the vector is A, magnitude of vector A, which we write it like this. You're familiar with this?
Yeah.
Magnitude of vector A. So vector A is, let's say, 2i plus 3j plus 4k. So what is the magnitude? So this is square root of 4 plus 9 plus 16. That is square root of 29. Right, beta?
Yeah.
So if you were to square it up, you can write this as A dot A. Makes sense, right? What is A dot A? Or scalar product of two vectors. That is magnitude of A times magnitude of B times cosine of angle between the two. So if you were to apply the same to here, you will get simply A squared. This expression comes in very handy when you're trying to find the angle between two vectors algebraically. If you're trying to find the angle between the vectors algebraically, then this is a very helpful the equation. Now, if I were to write A as sum of two vectors, B plus C, how can I do that? Well, let's say this is A, this is B, this is C, right? Then if you are comfortable with the geometric representation of vectors, then you know that B plus C vector is a vector. Are we comfortable there, beta? Beta, if anywhere you're not comfortable, you can keep asking questions and I'll try and explain it from different angles, so that will improve our understanding. Okay, beta?
Yes, sir.
So now if I were to do A square, which means I'm trying to do B plus C square, so this can be written as B plus C vector dotted with B plus C vector. Okay? So case in point, you are given two vectors, P plus Q is equals to R. Now you're also given that the magnitude of P is equals to magnitude of R. Right? Magnitude of P is equals to magnitude of R. Then the question, this is actually JEE Mains 2019 or 2020 question, I think 2019 question. And it says, what's the angle that the resultant of 2p vector and q makes with q? Resultant vector of 2p and q. That means what this vector, what is the angle between this vector and q vector? Okay. So let's see what are we given here. P vector is equals to r vector. R is p plus q vector. Correct? Square them up. What do you get? I can write this as p dot p. And what can you write here? You can write p plus q dotted with p plus q. Same logic. Then if you were to expand the right hand side, what do you get? By the way, whenever somebody tries and says what is the angle between the two, then if there is any way we can find out what this is, that would help, right? So what is the second term here? What do you get? That means the two vector must be perpendicular.
Perpendicular. Yes, sir.
And interestingly, this method, this approach comes in very handy if you are taking a algebraic approach. Geometric approaches might work out in certain cases, we'll see. But we need to have more than one weapon in our arsenal, okay? But with that, we'll stop here and we'll resume tomorrow, okay?
So just one thing.
Yes, beta?
In this, if I'm not wrong, if we're solving this, won't we get 2p, like 2 of whole pq, p plus q?
Beta, which part?
Wait.
Let me just write them. So this is 1, 2. So where is your question, beta?
So in part 2, we're saying 2p dot q, right?
Why? Because p dot q is equals to q dot p. Both are scalar, no? This is a scalar product. So what is p dot q? Magnitude of p times magnitude of q times cos of angle between the two.
Yes, sir.
Polar angle between the two. Correct?
So but the 2 is for both p and q, right? Like the p and q should be in, p dot q should be in brackets.
Oh, yes. But you can always write this as 2p into dotted with q, right? Won't that be the same thing? What will this be?
Oh, right.
2 times magnitude of p times magnitude of q times cos of angle between the two. And because 2p and p vector are in the same direction, so the angle with q will remain the same. Correct, Nabita?
Yes, sir.
Okay. So once again, this is p, this is 2p, let's say this is q, and this angle is the same. So hence we can do that. Okay. But just as a slight, so I'm going to stop the broadcast. Just give me a quick second.